Hello and welcome to another IoT Central webinar. I'm David O'Hara and I'm the Managing Director at IoT Central. I'd like to start by thanking Ground Control for sponsoring today's event. Today's webinar is the fourth in a six-part series. It's titled, How to Choose the Best Networking Technology for Very Remote Locations. Now I'd like to introduce today's speaker. Oliver Potter is a COO at Ground Control. Oliver, when you're ready, let's get started.
Thank you, David. It's great to be back here again with IoT Central. I think this is the fourth webinar in our six-part series. So today we're going to be talking about the different types of networks, and I don't want to take up too much of your time, so we're just going to jump straight in. At high level, we've kind of categorized these into licensed and unlicensed spectrum technologies. So let's dive into that, and then we'll kind of go through what we're really talking about. So licensed spectrum is where you've applied for a license, and that might be at a global level or at a kind of a local country level, or it may even be more local than that in some jurisdictions. And really, licensed spectrum is where all of our mobile phones operate today. So your narrowband and LTN IoT standards are cellular-based services on licensed spectrum. And then in a satellite context, most of the satellite services are using licensed spectrum. Kind of Iridium and Inmarsat, the kind of the big giants here in IoT, absolutely are. So their messaging and their IP services part of that licensed spectrum. And the advantage of using a licensed spectrum is it's dedicated to that use case. So you're not going to get interference. You get a higher guaranteed quality as a consequence of it being licensed. So that operator or that network operator will make sure that the service is really working, and they don't have to worry about volume of traffic or interfering traffic from kind of other competing services. But of course, you pay for it because they're rolling out a network and they've paid for that spectrum. On the unlicensed side, you know, at its very sort of basic level, this is your Bluetooth and your Wi-Fi, but you can kind of increase that range from that sort of Bluetooth, Wi-Fi, Zigbee thing to technologies that go over a much greater area. So this was sort of your VHF, UHF technologies kind of used around the world, but the big one in IoT is got to be LoRaWAN. So here you can set up your own gateway, you can connect lots of devices to it, and the beauty is you don't have to pay anything for that to use that network because you have created it. Challenge sometimes can be is lots of other people might be using that same spectrum because it's unlicensed in order to provide a kind of similar service or a competing service, and there can be kind of issues as a consequence of that. So it depends where you are. If you're in the middle of nowhere, unlicensed spectrum could work really well because you're unlikely to have interference, but in other places you might do. So at a high level, kind of some competing kind of ways of the models, the sort of the business models here are put together. So how might you consider these different technologies for an IoT rollout? So what we wanted to kind of bring the idea here is you can use both of these in a complementary way. So you could use unlicensed spectrum, so a LoRaWAN solution, in order to connect things locally to you, and then you might backhaul that over a satellite network or a cellular network or a fiber network in order to kind of connect to the main internet. Equally true, you might want to just connect your devices dedicated to a licensed network, and that might be for a whole host of different reasons, and that's what we're going to break down over the next couple of slides. So let's start on the left and kind of talk about that. So I'm going to do a little bit of a look at LoRaWAN. So if you're not familiar with LoRaWAN, it is probably the main technology here in the IoT space. So it's got a sort of maximum data rate of 50 kilobytes. It's license free, so it's very low cost. It certainly doesn't cost you anything to actually operate the service. It's a low frequency, so it's got really good battery life. So you've got generally, you know, up to a few kilometers of use on a low frequency. Therefore, your battery life is correspondingly very good. It's secure, and many people will be familiar with it. And this isn't a presentation to really talk to you in depth about LoRaWAN. So if you're interested, go and look it up. There's loads of space. Will come and talk to us. But once you've created that network of devices, you then have to consider how do you actually get that to connect to your servers. And that's where you'll need some kind of gateway that will connect to, I guess, the internet, and then probably to your servers that will probably be in the cloud. So if you've got fiber connected to fiber, absolutely the obvious choice. If you're in cellular range, probably quite a good idea to connect it to cellular because it's very, very cheap. But of course, you might be in the middle of nowhere. This might be farmland or agriculture, or this might be even sensors around a container ship or a ship. In those circumstances, you're going to have to use satellite. And there are some brilliant choices for you to kind of do that backhaul. So illustrating here a number of different choices, you've got all of your different sensors, and then really right in the middle of the slide, I've put 3 different options here. So the number one option that we work with customers around and kind of doing a whole load of trials is using a Certus 100 product called the Rock Remote. It's a narrowband TCP/IP service, or it can use messaging as well, but it enables you in a low power way with a very reliable service using the Iridium network to connect that LoRaWAN series of sensors back to the internet. Constrained with power, probably don't need that much data through it. It's a brilliant choice. If you've got lots of power and you can justify paying a bit more, and you can, that you might have people nearby and want to give them an internet service, then the Starlink would be a really good choice as well. But you've got to be using 50 watts of power. Therefore, you definitely need power in order to use that, and you're going to pay more in all likelihood for that connection than you would do over Certus 100, but you do get a lot more for it. So if you can use it and justify paying for it, it's a good option. And then on the bottom, we've got a sort of geo service. So this is geostationary orbit. This is from Viasat, Inmarsat, and this is their VGAN service. It's very good, slightly higher speed than you would have on Certus 100. So it is a good choice. Kind of, there are some constraints. You have to have a view of the sky where the satellite is. So it can't be behind a hill, or can't be kind of really far north or really far south, but definitely one worth considering as well. So you use those gateways with your LoRaWAN network. And the advantage of doing it this way is your cost per end IoT sensor is relatively low. So you've kind of, maybe you've got a farm in the middle of Africa and you're doing some sort of smart agricultural solution. You don't have to pay for a satellite connection for every water sensor or water moisture sensor or every kind of irrigation valve. You can do that through LoRaWAN and then only pay for one backhaul or a couple of backhauls depending on the geographic area you're covering. So it effectively reduces the per sensor or per actuator cost of using satellite. So it's a great choice. But of course it has limitations. The limitations are there's only so far your own LoRaWAN network can broadcast. And if your devices move or over a broader geographic area, you're then going to have to kind of consider connecting them separately. And equally, if you don't have that many devices, you don't want to have the overhead and cost of putting in your own LoRaWAN gateway, you might as well connect them separately. So let's have a look at that, which is on the right-hand side. So satellite networks, they're brilliant. There's absolutely no limitation on the distance between your sensors. You can have one in Australia and one in the Arctic. That's absolutely no problem at all. There are a huge different number of data rates. So when I talked before about Certus 100 from Iridium versus Starlink versus beacon M2M, you've got different throughputs, you can pay different amounts and you can get different service levels. So really there's an option to kind of suit the use case that's there. These are less low power than a LoRaWAN kind of device might be. So you do use a little bit more power, but you can put these on solar powered batteries that will last in perpetuity as long as the battery still has kind of viable life in it. So we're often doing sort of solar power battery sensor kind of installs, and they can work for a long time. But equally, you can have one, these batteries can last for many, many years, even without a solar source as well. And I guess the beauty here is you're not requiring any terrestrial infrastructure at all. You don't have to have a tower or a gateway or anything. You can just put your device anywhere and it can travel anywhere and it can still be connected. But of course, you're now paying for a connection per device. So your per device cost is slightly higher than a large number of LoRaWAN connected devices would be. Clearly, if you had 1 or 2 devices, you wouldn't want to then put a LoRaWAN gateway because you're just putting in more additional cost into your solution. So, good example here. So we work with the American Signal Corporation, and we have helped them with their tsunami warning systems. So they wanted to be unlicensed spectrum. They wanted to be directly connected to satellites because of A, the geographical range, but B, they wanted to be a service that's absolutely guaranteed to work. They can detect tsunamis, and they can be guaranteed they'll detect them, alert that very, very quickly. And then obviously this is in a sort of safety kind of critical infrastructure scenario. You can then go and alert those coastal areas. And in this circumstance, using a LoRa or using generally unlicensed spectrum doesn't feel like the right answer. You wouldn't want to have any contention, and equally you probably couldn't string up a network where these devices are. They're just too far and too geographically dispersed. So that's what we talked about. Considerations around using a local network like LoRa versus directly connecting to satellite. How is satellite likely to evolve over the next few years? And I guess, if satellite becomes cheaper, do you bother with the LoRaWAN gateway at all, or do you still do that as things evolve? And clearly today there'll be a tipping point for a particular use case as to how many sensors you've got and when that makes sense, and that might evolve if the costs of directly connecting to satellite come down. So on the left, some really brilliant services from Viasat, Inmarsat and Iridium. These are brilliant combination of geo services and LEO services there. And I think you can kind of do everything you would want to today. Skylo in the middle. Skylo are now offering a narrowband IoT service that sits on the Viasat, Inmarsat satellites, and I think it's available in a few areas around the world, and I think they're going to roll that out to nearly global coverage, and that could be quite an interesting technology. Not seen the pricing yet to fully understand it. I think it's probably going to be comparable to sort of the Iridium and Inmarsat prices that they're already there today, but we'll have to see how that evolves. The big advantage potentially here is you can use sort of more off the shelf. It has to be the modern release 17 or newer modules, but you can use sort of more off the shelf modules that may help you design a cheaper device than you could do today. So there's an ambition that maybe that brings down the cost, and maybe it changes that tipping point between needing a LoRaWAN network and directly connecting your devices. Starlink, I've talked about their direct to device or direct to cell capability. I think that's kind of launching later this year. They've certainly announced very publicly they're doing that with T-Mobile in the USA. I believe that'll be a sort of Cat 1 LTE service. Again, needs to see pricing. A Cat 1 module is a bit more expensive than you would be on the narrowband side, but an interesting service, particularly in the countries where it might operate. So that could be interesting as we look forward. And then Iridium are also talking about rolling out a standards-based service as well. So there is definitely an evolution over time, looking towards a few more standards-based technologies. Hard to see exactly what prices might do overall, but it certainly might help access to modules, might bring down prices a bit, and it may sort of change that tipping point. So to summarize, unlicensed technologies like LoRaWAN, really good if you've got a lot of devices in an area where you could connect them to LoRaWAN, on a farm or on a ship or something like that. You have to then directly connect those LoRaWAN gateways to the internet. There's some great backhaul options. Clearly, fixed and cellular are great if you've got them, but there's sort of your Service 100, your BGAN or Starlink options if you're going out into satellite. And you can, of course, directly connect very cost effectively your satellite devices if they're over a broader geographic area, or you want them all on kind of guaranteed licensed spectrums. That's absolutely critical. And the available services will evolve over the coming years. I don't think there's anything groundbreaking coming, but it's going to certainly change the landscape, and it's very exciting. But if you're interested, come and talk to us. And I think, David, that's enough from me, and I'll hand back to you.
This brings our webinar to a close. I'd like to thank Oliver for his insights, and thank you to Ground Control for sponsoring today's event. You can view more webinars, including the previous editions of this series, at iotcentral.io. Thanks for watching.